On this video, I'm going to show you two examples of a system of equations and how to solve those. So in the handout, it always tells you the method that you have to use to solve those, but in reality, it doesn't really matter. You can choose any of the methods that we have talked about. You can use addition by elimination, you can use substitution, or if you want to do graphing, you can also do the graphing method, okay? So right now, this first system of equations, I'm going to solve it using the substitution method, which is solving for one of the variables in one of the equations, and then the result is going to be substituted into the other equation, so that the result is going to be an equation with just one variable. I will solve this variable, and then I'm going to back substitute into the other equation to get the value of the second variable. Okay, that's going to be the process, but let's go ahead and do it. So the first thing that I'm going to do is I'm going to solve for y on the first equation. And the reason I'm going to solve for y is because the y is already by itself. It doesn't have a coefficient or a big number in front of it. So it should be fairly simple to solve for y on that equation. Okay, so let's take that equation. I'm just going to call that equation 1. Let me just write the number in here, equation 1 and equation 2. So I'm going to solve for y in equation 1. Okay, so equation 1, that's y minus 2x equals 6. And what I'm going to do here is I'm going to send the 2x to the right side of the equation. That way those two x's cancel out. The result is y equals 6 plus 2x. I'm not combining like terms because I don't have any other like terms in there. Okay, so I solve for the first equation. I'm going to call this equation 3. Okay, that's a new equation. The next step is I'm going to take this result of solving y, and I'm going to substitute it into the other equation, not equation 1, but into equation 2. Okay, so instead of writing y, I'm going to substitute the y for that expression that I just found, right? Because this is what it says. Y equals this new expression, 6 plus 2x. That means I can replace any y in the system for 6 plus 2x. Okay, so let's go ahead and do that. Next step is going to be substituting equation 3 into equation 2. So what is my equation 2? 6y equals 12x plus 36. And this is where I'm going to replace the y for my new expression. So 6 times 6 plus 2 equals 12x plus 36. Okay, so at this point, I'm going to get rid of the parentheses, try to solve for x. So distributive property, that's 36. 6 times 2 is going to be 12x equals 12x plus 36. Now at this point, can you see that the left side is going to be equal to the right side? That's 12x plus 36, that's 12x plus 36, right? And I mean, you can keep solving. I'm just going to subtract 36 from both sides, right? And that's going to cancel out the 36, left with 12x equals 12x. And no matter what you do, you're always going to have the left side equals the right side. Okay, so what this means is that those two lines are completely identical, or those two equations that I have to begin with, they are completely identical. They are the same equation of the line. So if you were to graph those two lines, this is going to be equation 1. And then this is going to be equation 2 también. Okay, so this system of equations means that as long as any of the values satisfies one of the equation, then that value is part of both systems. Okay, so the way we're going to write the result is x and y, whatever value, as long as it satisfies either of the equations. So I'm just going to write one of the two equations that I have in there. Okay, so this can be one of the results. It can also be, any point, as long as it satisfies any of the equations that I have in the system. So either or of these two options is going to be the correct answer. Right? Any point is as long as it's part of one of the graphs. So that's going to be the correct answer for the first system. Okay, so let's see what happens on the second system. Let's try to solve this second system of equations. It's completely different. Again, you can do it by substitution, you can do it by graphing, or you can do it by addition by elimination as well. Okay, so let's see what is going to be the easiest method to work this system. Since everything is in the form ax plus by equals c, right, or x's plus y's equals numbers, it looks like addition by elimination is going to be the easiest way to solve this. Okay, and addition by elimination, I have to convert one of the equations into a similar equation, into, well, the same equation but a different form, so that one of the variables cancels out if I add both equations. So if I were to put a big plus sign in here and add those two equations vertically, one of the variables has to disappear. Okay, so that's the purpose of addition by elimination. So let's see. I'm looking for a variable that has opposite signs already. That's a big help in order to start doing this transformation. And I see that the y's, they have opposite signs. So it means that I have to multiply one of the equations times one number, and chances are that's going to lead to the result. Okay, so my coefficients on the y are going to be positive 16 and negative 8. So it looks like I have to make both of those the same coefficient with different signs so that they cancel out. Okay, and the only way that I'm going to be able to do that is if I transform the bottom equation somehow so that this number becomes 16. Now I have a positive 16 on the top and a negative 16 on the bottom, right? So what do I have to multiply this number so that it becomes a 16? 2, right? Because 2 times negative 8, that's going to become a negative 16. And once this is negative 16y, those two are going to cancel out, right? So I'm going to multiply times 2, but I'm not going to multiply times 2 only that number. I have to multiply times 2 the whole equation. So I'm just going to do this small transformation, multiply times 2 the whole equation. Okay, so the top equation remains the same. Top equation remains the same. Now I'm going to do distributive property of this number 2 into the whole equation. Okay, so 9x times 2, that's going to be 18x, and then negative 8y times 2, that's negative 16y, and this is the purpose, right? We want to make those two numbers the same but with opposite signs so that they cancel out. And then 2 times negative 8, that's the last thing, and 2 times negative 8, that's going to be negative 16. Okay, so at this point I have to add those two equations in order to cancel out one of the variables and then back substitute the result into the other equation. Okay, so I'm going to add those. 18, or 2 plus 18, that's going to be 20x. These two guys are cancelled out. That's the whole purpose of doing this addition by elimination. And then I have 16 minus 16, and that's going to be 0. Okay. So we have a new equation in here that we have to be able to solve. 20x equals 0, and that's perfectly fine. Now I'm going to try to solve that equation. If I divide by 20 both sides, right, I'm going to have a result of x equals, what is 0 divided by 20? That is a real number, right? 0 divided by 20 is 0, and that's perfectly fine. So if it was 20 divided by 0, that's when we don't have a result. Okay, we don't really have a result. But 0 divided by anything, the result is always 0. Okay, and now we have the first value for our system of equations, right? What is the solution for the system of equation? X equals 0. Now I have to find the value for y, right? What is going to be my value for y? What I have to do now is take this value and back substitute into any of those two equations. Okay, so I'm going to call it back substitute. Back substitute in equation 1. You can do equation 2, it doesn't matter, it's going to be the same result. Okay, I'm going to take equation 1 because it doesn't have any negative signs. So I believe it's easier to deal with an equation that is all positive signs. It's less probable that we mess up in the way. Okay, so I'm going to substitute my value for x in the x's, and then I'm going to solve for y. Okay, so 2 times 0, that's going to be 0, plus 16y equals 16. So this is the same as 16y equals 16. Now I'm going to be dividing by 16 both sides. So y equals 16 divided by 16, which is the same as y equals 1. Okay, so it looks like my second value, or my value for y, is 1. Okay, so this is my solution for this system of equation. What this means is that if I graph these two equations, right, let's say equation 1 goes here, equation 1 goes here, and since those two equations are different, right, because I got two results, right, this might be equation 2, and this point over here where the two equations meet, or the two lines meet, this is my result, which is x0 and y1. That's x0 and y1. That's the coordinate where those two meet, right? This is just a sketch, right? This is not accurate, it's just a sketch. If you were to grab those two lines or those two equations, those two lines are going to meet somewhere, and that is going to be my solution. The opposite happens on the previous example, right? Because I'm trying to solve for the value for x and the value for y. That satisfies both equations. And I reach a point where, the left side is going to be equal to the right side at all points, right? At all times. So that means that it doesn't matter which number you substitute in here, right? You can substitute 1 or 2 or 3 or 4 or 5, right? Those are going to be all of these points, right? All of the points, as long as they fall into one line, they will fall into the other line as well. Okay, so this is how you report the result when you don't have an x value or a y value in a specific, right? Where they don't meet in two places. And it's not on these examples, right? But you can also have the situation where equation A or equation 1 looks like that, and equation 2 looks like that. They're parallel. They're never going to meet, right? So we're not going to have a result in here. And the way that we report this is no result. Okay, no point where those two lines meet, right? 1 point where those two lines meet, and two equations or two lines that fall on top of each other. The value is also any point as long as they satisfy y equals one of the equations of the lines. So these are the three different situations, and that is solving those two examples in there. So go ahead and let me know if you have any other questions, or if you want me to do some other examples. I will gladly do those.